If energy is not drawn back into the liquid, its temperatures will decrease. Okay, therefore, vaporization is an endothermic process. Okay, so once again, if energy is not drawn back into the liquid, if that energy is not drawn back to the liquid, the temperature will decrease. Okay, and when this happens, right, this is an endothermic process or vaporization. Okay, so if we think about vaporization, right, you guys ever be cold in the shower, right? You got some liquid on you and then you notice like you're cold. Well, that's an example of vaporization, right? You got an endothermic process taking place on your shoulder right now, right? So that liquid molecules is transforming to a gas molecules. And we understand what endothermic process is, okay? That is basically a cold reaction, okay? So that's just an everyday example, okay? Now on the opposite end, condensation, right? If you got two opposite processes, what do you think is going to be the other process? It's going to be an exothermic process, right? So that means that we release energy, okay, when we have those gas molecules being converted to liquid molecules, okay? So this is an exothermic process, okay? So vaporization, okay, it definitely requires input of energy when you're trying to overcome the attractions among these molecules, okay? So let's just look at this table. I love looking at tables, okay? So right now we got 4 different liquids. We got water, isopropyl, alcohol, acetone, and diethyl ether, okay? Once again, chemical formula you got going on here, right? We understand this oxygen is bound to a hydrogen. We understand the isopropyl alcohol, right? This is another thing too, right? If you're trying to figure out how they're connected, right? Think about the naming of them, okay, and as well as looking at the chemical formula, okay? Because I know that everybody's like, well, how you know that this is going to be connected that way, right? Well, the alcohol, we know alcohols is OH bonds, okay? So even if we can't understand the chemical formula right now, I know that the alcohol is OH. That's why you got to know how to name those compounds. You got to be able to name those compounds. Acetone, right? This is going to be that ketone. Like I said, this one might be a tough one, so we'll get later on to that. And then diethyl ether, right? If you haven't covered that yet, we're naming, right? But if you understand ethers, we know that that's going to be bound to that carbon and oxygen, as we mentioned in that earlier example. Okay, so we got our 4 different liquids here. Let's look at our boiling points. We got water, boiling point is 100 degrees. Isopropyl, 82. Acetone, 56. Diethyl ether, 34. So let's talk about these 4 different liquids and how they're being related when it comes to this energy, okay? So the amount of energy, okay, that we need to turn this from a liquid to a gas, right? We call this the heat of vaporization. Heat of vaporization, all right? Or enthalpy. Y'all remember energy is heat, right? Energy is heat. Heat is energy. Enthalpy of vaporization. That should be a reminder for you guys. If not, check out that Chem 1 playlist. It's endothermic vaporization. It's endothermic. If we remember about endothermic processes, we got to understand that endothermic processes are absorbing energy. And if you're absorbing energy, right, you got a positive value, okay? So our vaporization, enthalpy of vaporization, right, if it's an endothermic reaction, we understand it's a positive value, okay? And vice versa, if you got condensation, it's an exothermic process, we understand that this is a negative value. Okay, going back to that enthalpy, right? All this chemistry stuff, it never really goes away. You learn one thing, you're like, okay, I don't got to really learn about that no more. No, you got to keep that right here in the back of your head, just in case if you look over there, you can just pull it out. Now, right now, you got to pull out enthalpy, okay? So, let's look at this point here. Temperature increases, right? If the temperature increases, the vapor pressure will increase. Okay, the rate of change in the vapor pressure depends on the strength and the intermolecular forces. Okay, once again, let me read that again. The rate of change in vapor pressure depends on the strength of the intermolecular forces. So let's go back to this table. What do we notice about water? It had the highest normal boiling point. Thinking about all of the intermolecular forces, water, I see H2O. We got hydrogen bonding going on here. Isopropanol, we got an OH bond, so another hydrogen bonding going on here. Now this is pretty strong, but not as strong as, the water, of course. Acetone, we think about acetone, we're going to understand, right? No hydrogen bonding going on. So this is the reason why we're going to see a little lower boiling point. And then diethyl ether, no hydrogen bonding, no dipole-dipole, etc. This is the lowest boiling point. So if we increase our temperature, the vapor pressure will increase. Increase the temperature, the vapor pressure increases, right? So at normal temp it's at 45, but if we increase the temperature, right? Increase the temperature to the boiling point of that, we're going to see the vapor pressure lowers. So if it's lowering, that means that it's actually increasing, right? Because it's easier to be evaporated, okay? So you got a low vapor pressure compared to like water, all right? Water, hydrogen bonding, especially with two hydrogens, so we're going to see that, right? Not as much difference.